Vectors are lines that are drawn to represent a certain value. So this is a vector here, and it represents a value of 50 meters per second. So the scale will be different on the thing that you're viewing. So it looks very different, obviously, on a phone to a laptop. But you could choose a scale of, say, 1 millimeter equals 1 meter per second, and you could draw this line 50 millimeters long. So it's a line that's got a magnitude, and that magnitude is the value 50 meters per second. It's got a point of application, which is this dot here. So it starts here, is drawn 50 millimeters there, and it's got direction. So if we look at the compass here, this is heading in an easterly direction. So this is a car or boat or whatever plane that's moving at 50 meters per second in an easterly direction. Other quantities that we can draw with vectors are newtons, force. So these are the two ones you'll come across: velocity in meters per second and force in newtons. Now we've got two forces here, 50 newtons. So again, I could have drawn those 50 millimeters long, both of those. Our point of application. Now if we've got two forces acting, there's going to be a resultant force. This one's pulling this way, this one's pulling down, so my guess is it's going to go somewhere over here. And we use what's called a parallelogram of forces to find that resultant. We draw a line parallel to this force, the same length, and then we draw a second line parallel to this force, again the same length. And then from this corner to this corner is our resultant. And if you look, that forms a triangle where this is the hypotenuse. And if we measure the scale, it would be 71 millimeters to give us 71 newtons. So what we're saying there is 50 pulling this way, 50 pulling down, gives us 71 pulling at a certain angle here. We can put a protractor on there, and 45 degrees. So that's our resultant, 71 newtons at 45 degrees. This is another force, 100 newtons, but it's not acting in line here or here. It's acting at an angle to this reference line. And we can put a protractor on there, and we can see that it's 30 degrees. So we've got 100 newtons acting at 30 degrees. Now any vector that's acting at an angle has got a vertical component and a horizontal component, and we want to find both of these components. So it's like saying you can go from here to here 100 newtons at 30 degrees, or we can go along a certain value and up a certain value. And if we draw them to scale, we can measure these, and we'd get a vertical component of 50 newtons and a horizontal component of 86 newtons. Now, a more accurate way would be to do it by calculation. To find the horizontal is the cosine of this angle times the hypotenuse. So times this 100 newtons. So cosine of 30 times 100, 0.866 times 100 gives us 86.6 newtons. If we look back at it was our measured by graphical means, 86 newtons. Fairly accurate. The vertical we can find by the sine of the angle. Sine of 30 degrees times 100, and the sine of 30 is half times 100 gives us 50 newtons, which I think was exactly the same as the measurement. So there's our answer there, 86.6 and 50. We've got another one here, 50 newtons, and again we're going to find its horizontal and vertical components. This is acting at 17 degrees to the reference. So drawing, we get a horizontal component of 48 newtons and a vertical component of 15 newtons. Again, we'll calculate that. Cosine of 17 times 50 gives us 47.82 newtons, which is close to our 48 newtons that we measured. and vertical is going to be again the sine times 50. 0.292 times 50 gives us 14.62. We measured 15. Now what we're going to do with the two answers from the two vectors that we've got is 100 newtons and 50 newtons, is we're going to add these two components. Now graphically what we can do is we can take this length and then draw the second length on, and then we can go up this blue and this blue, add those together, and then we can draw this in and measure this distance. So I've got 65 there and 134 there, and if I measure this it would be 150. So we're saying that the resultant of these two together is 150 newtons at a certain angle here. We can put a protractor on there and I get about 26 degrees. By calculation, what I'm going to do is use our calculated values and add those to give us 134.42 horizontal, and our vertical components to give me 64.62 newtons up. I'm going to draw the triangle and then calculate this hypotenuse using Pythagoras. Now, Pythagoras says if we square this and we square this and we add them together, take the square root, we will get this hypotenuse, and we get 149.15 newtons. We can find the angle using trig. I'm going to use cosine. Cosine of that angle is adjacent over hypotenuse, so it's this value over hypotenuse, which is 134.42 divided by 1.9.15 gives us just over 0.9. That's the cosine of that angle. So if we want to find the angle, we have to find the inverse cosine of that number. And the inverse cosine of that gives me 25.68 degrees. So my final answer is 149.15 newtons at an angle of 25.68 degrees.